Hi guys, welcome once more to our differential equation class. And my name is Peter C. Duggar Jr., instructor of mathematics at the University of Liberia and your math tutor. So in this video today, we will be discussing verifying differential equations. So when a differential equation is given and a solution is given, how do you verify that that solution is actually a solution to the differential equation? So we've been solving few problems. This is the third problem now. So let's look at this problem quickly. The problem says dy by dx equals y squared plus 25. Y equals 5 tangent of 5x. So how do I know that this is the derivative and this is the function? So I know that there is a derivative from this derivative notation, dy by dx. So since this has no dy by dx or y prime or f prime of x, it doesn't have any differential in it. It means this is actually the solution, right? That we need to verify. So to do that, we take the solution, y equals to 5 tangent of 5x. So in this problem, we only have y prime equals to y squared plus 25. Because this dy by dx means y prime. That's another notation for it. So I already have y. So anywhere I see y, I'm going to replace it with 5 tangent of 5x. So I need my y prime. So I differentiate this function. So y prime now equals to 5. Now, we told you that given a function y equals to tangent of x, or in general tangent of some ax, y prime, which is its derivative now, will be tangent of x derivative is secant square of x, or of that angle, which is ax, times the derivative of the angle ax. So in general, you will just have y prime to be the derivative of ax is just a, so it's a secant square ax. So this is the derivative of tangent of an angle wherein the coefficient of that angle is like greater than 1. So we apply the same thing here. Tangent of 5x. So our a now is 5. So it's just equal to, it's just like saying differentiate tangent as just tangent of x. So the derivative of tangent is secant square of x. Now x is the angle, which is 5x. Times, then you differentiate the angle of tangent. The derivative of 5x is just 5. So this method is called the extended power rule. So you differentiate, then you differentiate inside, or we also call it the chain rule. Differentiate inside. So we have y prime now to be 5 times 5. You don't multiply this number by the angle. So we multiply it by the coefficient of the secant. So 5 times 5 is 25. Secant square of 5x. So what do we have? We have our y prime now to be this expression. So we go in the problem. Anywhere we see y prime, we put 25 secant square of 5x equals, anywhere we see y, this y. So y is equal to 5 tangent of 5x. Then we have to square y. So we square this y portion. So if y is squared now, we have raised to the second power plus 25. So our duty now is to simplify, that expression. And if we simplify that expression, we can bring in some identities for what is there. So we have 25 secant square of 5x is just equal to, now 5 tangent of 5x times 5 tangent of 5x is like 5 tangent of 5x times 5 tangent of 5x. So 5 times 5 is 25. Then tangent of 5x times tangent of 5x is tangent square 5x plus 25. So we have 25 secant square 5x equals, now 25 and 25 is in both terms, so we factor out 25. And then we'll be left with tangent square 5x plus 1. But we know that tangent of x, tangent square x plus 1 is just equal to secant square x. So given that x now represents 5x, we will just have 25 times secant square 5x. So 25 secant square 5x is equals to 25 secant square 5x. So you have then verified that actually this solution is a solution to this differential equation, since through our verification the left hand side is equal to the right hand side. So thanks ever so much for watching. See you in our next class.